Hmm. Yeah, I think so.
Okay, are you bringing your dread?
I need to go back into that. Uh,
Testing. Okay, yeah. I had to turn my mic on. It was broken when I opened OBS.
hmm.
OBS is up to date. Lame.
Okay, so I need to get to another continent.
Yeah, just take the Zeppelin, I think.
Heck yeah.
Because I'm like right by the Zepp tower anyways. Okay, you ready for a math thing?
Yeah, I think so.
Okay. You see this? Make a tree of this one.
Okay. Need to open things.
The way prefix is usually used is with parentheses. And this is a step in that direction.
So prefix is normally used with parentheses? Huh.
Yes. But there's a thing that it's useful for.
Okay. Uh,
Also, for people watching, you might want to try stuff before you see the answer. Like, try to do it yourself and then, like, pause the video and try it. At least for some of them. Okay, let's see. Join stream.
And I'm walking to
Pop
Zeppelin.
out.
Okay. Then I'm happening. This. No. I kind of have to navigate, and then that's on. Yeah. Okay, I'm just gonna walk to Zeppelin for now. Okay. Let's,
You see the problem? You can start thinking about it.
yeah, I'm looking at the problem. Okay. Okay, so I think it's 3 plus 9.
Yep. The math isn't too hard, but try making a tree.
Gromgal. Wrong place. Ew. I'm following another guy who's going to Undercity. This should work out. Okay, tree. Uh, what is it? Parentheses. Okay. So. There. So the first thing we're doing is a plus operation. Uh, First thing is a plus operation with 4 and 5, and that then make it. No. Okay, so we're doing a plus, and then this would be. Then we make. Okay, so this is the first thing we're doing. And then we. This is an addition as well. Okay, I think I made the tree.
Yep. Okay.
Okay, so it's parentheses, so it goes on the left because it's the first thing we're doing.
Okay, what if I give you this? Can you figure out what the tree is?
Okay. This is still be open. Okay, what is this? Hmm. Wait. Okay. Just gonna question mark. Delete. Okay, so where's the first thing? I think parentheses also applies to like whatever has more parentheses. I think something can have multiple parentheses. What am I
Yeah,
really
sure. The
thinking?
the more nested ones happen first. I think you arrived at the Zeppelin.
Uh, Is it gonna jump off, but I don't have like blank? Uh,
Okay, go follow me.
okay, so when I'm trying to figure out the parentheses, there's these parentheses, which kind of apply to everything, I think.
Yep.
There's like the two ends, which is everything. So like, to make this easier, I'm just gonna try to get rid of them until I figure out which one to do first. Okay, then there's two other parentheses. Okay, so order is left from right, like addition, subtraction, and there's not any division or multiplication, so don't need to worry about that. So just like left to right. So first thing we do is this one. So what is this? This is subtraction operator, and then wait, can you go back? No, I don't know. Delete. Okay, subtraction with 2 and 1. So it's 2 take away 1. So that would be 1. It's in parentheses, so I'm just gonna put it on the left for now. Because I think it's like the first thing we do. Okay, then what do we do next? We do this plus operation. Okay, so I guess I can also do something like wait, do these parentheses matter at all? Like the ones on the outside? I'm not sure if they affect anything.
Not exactly.
Okay, so then what did I do from here? I turned the minus into a 1. Okay, the next thing is an addition. 1, 1.
Hello, Peru, Beba. if you're gonna flame, I will in fact just block you. The comments on my video were just a bunch of flames, and then you come in my chat and flame. So, FYI.
Okay, that's two. Okay, so this got two. Okay, then that's a big operation. Wait, so what did I do? I need to rewind. Okay. Turn this into a 2. That's what I did. And then this is also a 1. Okay, bit messy history, good enough. Okay, so then, this is an addition, and it's adding, now what is it adding? 1, 2, 3, 1, 4, 2. And, okay, so minus 2 on, okay. What am I doing? I kind of just want to have these out of the way for now. Then, okay, so this is an addition, and it needs a 1, 2, and 3, and a 4. Okay, now I need to figure out where this 1 and where this 2 go in. Okay, if we do the 1, okay, the very first thing we did was to get the 1, so I think that still goes on the left, because that was the first thing we're supposed to do. And then the second thing we did was get the 2, so I think this is the second on the left, because that's the second thing we're supposed to do. And then 1, 2, 3, 4. Okay, so I think I made it.
Okay, it's not super important, but that's not the order I would put them in. I would put them in the order that they're in the thing. So it'd be 1, 2, 3, and then this thing. The parentheses are for grouping things together is a good way to think of them. They're saying like the things inside the parentheses are connected together with each other more than they're connected with the outside stuff.
Okay. Things inside. So instead of doing it like this, it'd be like 1, 2, 3, and then the 1, and then 4, and then the 2. So this would be like the order you'd put them in, I think.
Yeah, that's what I would do.
Yeah. I wasn't sure whether to do it like that or put them on the left. I decided just to put them on the left because they were in parentheses, because I thought that was like the first thing you're supposed to do. But then it's about like what to do inside of them, or okay, so I think you like do the operation and then you can kind of just remove the parentheses, like how I did with this. Like I did the operation and like I got the result, then I can just remove the parentheses. Like, okay, this becomes a 2. And then I don't need to move it to the left now. It's just like I did it. So
Yeah, kinda.
okay. Like you do the
Yeah.
operation and then that's it.
Speak quickly. What now? Our time will come.
Okay, so the rule is pretty simple with prefix and parentheses. Parent. Does this make sense for how the parentheses work?
I don't know. I don't follow. Like, I could try to translate
Okay, well,
that.
compare it with your tree, and look at each of the parentheses, and then what the parent and the child in your tree are.
Okay. Parentheses, what the parent and the child in the tree is. Okay, so,
What would you ask?
everything in here
What
is in
it?
parentheses.
Beware the
Uh, okay, so,
That better be good.
well, parent, so,
Remember,
okay, I think this
patience,
is a parent,
discipline.
or, wait, how does parent work? Okay, so the first thing is the parent, then there's the child, and the second child. So, I think this would be a parent, then this would be second child, and then this would be third child. This is also parent, second child, third child. And then I think these are both
Wait,
children.
you're saying second child, third child. The 2 would be the first child of the minus.
The two.
There are... How many children does the minus have?
Wait. Two is first child, one is second child, minus is a parent. It has two children.
Yes.
Hmm. Okay. I don't consciously remember contradicting that.
You call the 2 the second child, and the 3 the third child. Or the 1 the third child.
uh, uh,
I think. I thought
okay,
that's what you
I
were
think
saying.
so. Hmm. I don't know if delay could affect it or if I just misspoke and don't remember.
Okay, no problem.
I think this would be a third. Wait. Okay. If we take a look at it from like perspective, if we take a look at it from perspective of plus, this is first child, second child, third child, fourth child. And these would be grandchildren, so they're not actually children.
Yes.
Fourth child, fifth, sixth,
Mm-hmm.
and then we go from like left to right. This is parent. First child, second child, first child, second child. Uh, okay, so if we look at it from here as well, then like one would be first child, two would be second child, three would be third child, one would be fourth child, four would be fifth, second would be sixth. Uh, okay, I still don't really think I understand how the rule works though.
Okay, so let's do another tree. Grab the flight point first. Okay, you got flight point.
Yeah,
Can you hear me?
yeah, yeah.
Okay. Okay, so I'm gonna type in the problem, and you're gonna make the tree as we go along. Okay?
Oh, okay. Uh,
Okay, so I type in X. What do you know about the tree so far?
we're doing some kind of multiplication.
Yes, and where does the X go?
I don't know. Wait, if we're assuming it's the parent, then it would be on top right now, I think.
Yep. So
It
the
could.
X is a parent. Now,
Okay.
I'm
I'm
gonna
not
write.
sure. Okay. It might not be the final parent though. Like it's a parent of something,
Yeah,
but I'm
I'm gonna
not
go in order.
sure it's
I'm
like
not
the
gonna go
final
go
parent.
back and change it.
Okay. So X, and then a child is gonna be 2.
Yep. And then if I write a 3,
I'm guessing the child would be 3. I haven't seen it yet. Okay, it is.
okay. Now I'm gonna write another parentheses. I'm gonna put a plus.
Bear. I try to look around with right mouse button, and then I guess
Yeah. Don't worry, the enemies aren't that high level.
okay. You wrote a plus and it's in parentheses, which means it's the thing we do first, I think. Unless, wait, how does that work? Okay, what did I do with the last tree? With the last tree, it was like, thing was in parentheses, but it was still just like in order of left to right. So, I think
Look at the rule in particular.
oh,
To try to figure out what to
okay.
do. I think.
Parent, child 1, child 2, child 3. So, is assuming the plus is a child of the parent, then it should be in the child number 3 slot, which would be right here. So, is it the child of the parent? Okay. Child 1, child 2. I think it's a child of this operator. So, I'm gonna put the plus here.
Okay. And then I'm gonna type a 1. Okay. And then I'm gonna type a 2. I'm gonna put parentheses, and I'm gonna put a minus.
Okay, so wait. Okay, I think that minus is a child of the plus.
Does that fit the rule?
Okay, what's the rule? Parent, child. What? Okay, so.
I wasn't trying to say it doesn't, I was just asking.
Hey, that's a thing where, like, someone,
Sometimes they
sometimes
only
people
ask
ask
if it's
questions.
wrong.
Yeah. Does it fit the rule? Okay, let's see. So, yeah. Okay. Make it those two. Then I think minus is the thing we're supposed to do first. So minus is the very first thing we're supposed to do. We do it before addition, which would mean I don't think it can be the child of addition, for one. But then, like, does it fit the rule as well?
Well, what gets done first, parents or children?
Parents
General.
or children in general? I don't know.
Well, alright, let's look at a tree.
Like, children, I guess. Okay, it's like the way I read this tree is.
Okay, here's a
I,
tree I just... Oh, that has an extra thing in it. Okay, there we go. Which gets done first? The parent or the children?
okay, the children. We like operate on. We like figure out what the children are first, and then from there, we can then operate on the parent. like the parents kind of reliant on
Yeah,
the
you
children
figure
being
out what this part
operated
is
on.
in order to figure out what you're adding.
Like when I do
So,
it, I like read addition. Okay, I don't know what we're adding, so I can't continue. So I need to figure out what we're adding first.
yeah, so if something needs to come first, you said then it can't be a child.
Needs to come first. Ah, yeah, that's wrong because the children like always come first, I think. Uh, can you focus on the math thing again? I can't see it.
Computer is lagging so much, it's ridiculous.
Uh, hmm.
I'm gonna quit something quick, but there you go.
Okay, so I think the subtraction. Wait. Oh, there's actual things happening in WoW that seem dangerous. Entangling words.
Out of range. I can't catch that yet.
Okay.
I can hide my preview on my stream. That's cool.
Okay, so figuring out what the subtraction is. I think the subtraction is a child of the addition, so I'm gonna put that as a child of it. Addition can have 3 childs. Yeah, it doesn't just need to be. Unless it's infix. I think we're doing prefix.
Yeah, this is a prefix. The
Like,
first thing is an operator, so that's gonna be prefix.
oh right,
Okay,
that makes sense. Okay, so we have a minus.
right, now I'm gonna write a 5.
I feel like I might have been hesitant to add a 3rd child to the plus,
Well,
but I
yeah,
didn't
yesterday
really.
we were doing only 2 children of every math.
Okay. Okay, then what's the 5 at? It's for the subtraction.
Far away. Recharging.
Okay, and then after the 5 I'll write a 2.
Okay.
Okay, and then what if I go over here and I write a 1?
No, that applies to the addition.
Okay, and then what if I go over here and I write a 1?
That's gonna be with the multiplier. Uh, hmm, that's it. Make it right line. Okay, 1. That's gonna be with the multiplier. Huh. Having multiple children of multiplication seems weird. I don't know if we've covered that yet.
You can multiply things together, it doesn't really matter.
Changing.
Okay, so yeah, that's where the 1 goes.
Okay, and then at the end, what if I write a new parentheses and I do plus?
Okay, I think that would be over here, and it would just be a plus.
Okay, and then I will write plus.
Okay, so that's gonna be the child of that. It's gonna be plus.
Okay, and then I'll write 1. Then I will go over here and I will write 6.
Okay. Is that all of the tree?
Sure, yeah, that's the tree. Okay, now what I wanted to show you was you can figure out where everything goes as you go along when you're reading right from left. Because I wrote everything from right to left, or from left to right. Yeah? I started on the left and I just
Yeah.
wrote as I went along. And then you knew where
Yeah.
everything went in the tree as we went along.
Yes.
So, you can figure out where everything goes in a simple way. You want to figure out what that tree is worth? Add it up.
Okay. So this is just an addition of 1, which would just mean 1. Okay.
Yeah.
6. So this is gonna be 7.
Yeah. Since we're using parentheses, we can add numbers that aren't. We can add a different number of numbers that isn't 2. We can add 1 number or 3 numbers, whatever. Doesn't matter.
Okay, and then what's this? Subtraction. I have to take away 2. Okay, addition. So 1, 3, 6, 7. Okay, then multiplication. Wait, so is this? Uh, okay, multiplying multiple numbers. Okay, the way I want to do this is 2 times 3 times 7 times 1 times 7.
Yeah, that makes sense.
Okay. Uh, okay, so that's that. Okay, so what's 2 times 3? That's going to be a 6. Okay, we got 6. Now what's 2 times 7? 7 times... wait. 7, 14, and then 14 plus 7,
Blood and thunder.
20, so 21. So we're at
For
21
the horde.
times 1, 21 times 7. Okay,
Hold
I
on.
need to...
I'm
Oh,
not sure which things you're multiplying together. I thought you started with 2 times 3.
yeah, I got 2 times 3, which became 6.
I think write down what you're doing as you go along.
Okay.
Go with honor.
Okay, I'll just have a new thing, like here. 2 times 3, 6, and then okay, 2 times 3 equals 6. Then 6 times 7, Okay, what's 6 times 7? Okay, I want 7 sixes. Then how do you do multiplication with 6? I forget how you do multiplication with 6, but the thing I was trying was timesing it by 2, then adding those together 3 times. So 7 times 2 is 14, so 14 times 3.
That
Oh wait.
will work.
Oh wait, I think the other thing I was trying was double, double, then add itself, add the original number once. So 14. Okay, so we double it once. That gets us 14. Okay, then we double it a second time. That gets us 28. Then we add 7 to 28. 2, 30, 35. Oh yeah, so I got 21, I think. This is 35, I'm pretty sure.
No.
Oh. Hmm.
Okay.
Okay.
So what you said you were doing was you multiplied 7 by 2, and you got 14. Correct?
Wait,
So far?
7 by 2. Yes.
And then you wanted to multiply that by 3, right?
Yeah.
So take your text file and write out an addition. 14 plus 14 plus... Right? That's what you wanted to do?
Okay, 14.
Strength
Yeah,
and
so
honor.
then one thing
Victory.
I tried. Wait, am I off? Okay. That was the original thing I think I was gonna do, but then I tried to think of, I could do 7 times, 4, and then plus 7.
Why would that work? If you do 7 times 4 plus 7, how many 7s do you have there?
Then, that's gonna be 5 sevens.
And how many do you need?
I need 6 of them.
Right.
Speak.
Is this a rogue? We got killed.
I have no idea, but get the flight point.
For the horde.
Okay, where are you?
Oh, I just left, don't worry about it.
Oh, you're behind.
I'm
Okay.
finding my weapon trainer right now.
Okay, so what I can do is, okay, so what should I have done? 28 plus 14. So what's 28 plus 14? So 30 plus 12, 42. Okay, so I'm gonna try to think more about what happened. So you
Blood
want
and thunder.
like
Strength.
7
Stronghold.
times 4? Yeah,
How
7,
you do it, man?
4. Okay, so what's the first thing I'm trying to do? I'm trying to do 6 times 7. Okay, so I can double that twice to get 7 times 4. And what's 7 times 4? 28. Okay. Equals 28. And then 28 plus 14. Wait, is this what I wanted? I think so. Yeah. So I want 6 sevens. So this is 4 sevens right now, and then 14 is 2 sevens. So if I add those together, that would get me to 6 sevens. And so adding that together, I like take that to 12, and that's 30. So then that's 30 plus 12. It would be 42. Yeah.
Stronghold.
Okay.
Okay, yes, it is 42. What do you
Okay.
have left to finish the whole problem?
Okay, I need to times 42 by 1. So that's going to be 42. Wait, how did I do that? Okay, then 42 times 7. Alright, you can times 8, subtract 1 of itself. So that's going to be a double, 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 minus 1 of itself.
That will work. I don't know if it's the easiest way, but it's okay.
Okay, so 42 times 8.
It's not what I would do, but go ahead.
Okay, so double, okay, times 2. 84 times 2. I guess right now equals 84, then 84 times 2. Okay, so we'll get us to 4. Then we
It would
double
help
it.
if you wrote down what you were doing so that you didn't lose your place. Like, you're doubling 42 3 times and then subtracting a 42, correct?
Oh yeah, so I could like
So if you
write
just
that down.
wrote that down, then you'd know it. You wouldn't get lost that way.
Okay, so what am I doing? Like I have a 42 over here, and I need to get it to 7. So what am I going to try to do? I'm going to do 42 times 8, and then subtract 1. Subtract 142. Okay, let's do 84. So now I'm at 241, or 242s. Okay, 84 times 2. 80. 168. Okay. B 8. Yes, 168. Okay, so now I'm at okay, so double, double, double. So double, double, then a double. Okay, 160 gets us to 320 plus 16. Okay, 320 plus 16. So here, 20 plus 16. Okay, sounds 136. Yeah, 136. Wait, 136? 336. Okay, now 336 minus 42. Take away 42. Okay, let's take away 40. So that gets us to 1. So that gets us to 290. So that gets us to 290. And then, okay, what gets us to 290? 3, 3, 3, 3, take away 40 is 290. Okay, then what if we add 6? Then we take away 2. Okay, so 294. Okay, I think I did it.
Okay, looks right. There are easier ways to do multiplication.
Mhm.
So, are you familiar with the, like, standard way of doing multiplication?
No.
Okay, well, I will briefly show you. So, we were doing 42 times 7? That was it, right?
Yes.
Okay. 42 times 7 equals 40 times 7 plus 2 times 7. Does that make sense?
I think so. Let me try to do that. Okay, so 40 times 7, you can do like 10 times 7, 70, then like 70, wait, okay, 40 times 7 times 7, and then like what can you do with 40 times 7? Like double it and get 140, then double it and get 280, and then 2 times 7 and you get 14, then it's 280 plus 14. Okay, so 280, then you add a 10, and then add a 4. Huh. Okay, I'm not used to doing. I don't know if I've ever heard of that, or if I've ever done something like that, or if I did and forgot about it. And either way, seems useful. Huh.
Trust no one.
I don't think I've times numbers bigger than like 2 digits much. Or
Okay,
no, 1
so
digit.
a way to see that it works is this means you have 42 sevens added together. Does that make sense?
Oh yeah, and just 40.
So we
This
can
is
split it into
47.
40 sevens and 2 sevens, and that's going to be 42 sevens.
Oh yeah, that makes sense. So like, what do we have here? This is the equivalent of 47s. So if we just had like 40 of these, and then we added them all together, it would make 280.
Yeah,
And
7
then
plus 7
like,
plus 7, 40 times.
yes, that's 47s. And then like 2 times 7 is like, okay, we have 2 sevens, and that becomes 14. So like, so it's kind of like 47s plus 2 sevens makes 42.
Yep. So
42
you can do the
sevens.
same thing with bigger numbers. Like, if we're going to do 1, 2, 3, 4, 5, 6 times 5, you can split it with each digit. So you'd have 10,000 times 5 plus 2,000 times 5 plus 300 times 5 plus 40 times 5 plus 5 times 5. Does that make sense?
Mm,
You can go one digit at a time.
uh, okay, I think it would make more sense if it had like lines in between everything. Because I like read that and then I get intimidated by how long it is, like as an individual thing. Then if you like add
Yeah,
lines,
that
then
one
it
was a
seems
bit
like
long.
okay, so we can do like 10,000 times 5. That gets us to like 10,000 times 5. That's just like 50k easy.
Oh yeah, I wasn't asking you to actually solve it. I was just trying to show the method. Like, you could do it this way.
Yeah.
And it wouldn't be super
Uh,
hard because you're doing one digit at a time. Does that make sense?
yeah, so like then we do like 2,000 times 5, and that's like just 10,000. And 3,000 times 300. Yeah. I see the method. It seems very useful.
Okay. Now, there's a similar method you can use that works when both of the numbers have more than one digit. So suppose that we're multiplying 22 by 13. Do you want to try to figure out what you could do?
Okay, 22 times 13. Okay, I think the initial thing I'd try is just like, what's 10 13s? Like 10 13s, and that would be like 130, and then like another 10 13s get us to 260, and then like 13 plus 13, like how many is that? 26, and then 26 260 plus 26. Make it 260, 286. So that's what I would do.
Okay, that was reasonable. That worked. So, one way you can look at it is it's easier to do 13 22s than 22 13s because 13 is a more convenient, smaller number. So, what I'm going to do, I'm going
I
to say
feel
that
like
it
would
is.
be.
Go ahead.
Okay, I feel like the 22 is easier because it's a even number and it's using tens and twos, and those are things I'm used to.
Yeah,
I'm
I
not
can
as
see that,
used
but
to
when we do it
3.
this way, see how we end up multiplying 10 by 22, which is actually really easy? Multiplying by 1s is
220.
easy. This one has a 1 in it, so it makes it the easier number.
Yeah, with tens that you can
It's
literally
not that
just.
important, though.
Yeah.
Anyway, that's not the main point. It's not which number to do. So, we have 10 times 22 plus 3 times 20. That makes sense so far?
10 plus 22. Yeah, we just get 20.
Okay, but I'm not done. So, we can remember this method?
Oh shit.
So we can split it a second time. You want to try to do that? And we
Uh,
can split it into more different parts to make it easier.
I can't. Is there something attacking? Not anymore. Okay,
You can just
so
fly to Silver Pine if you don't want to get attacked.
I am forsaken.
silver pine. Hmm.
Watch your back.
Okay.
What is it?
Okay, so that seems interesting. So what did we have? We have 22 times 13. Okay, and then I was doing it with like 10 13s or whatever. Okay, but you did it with the 13s. So what did you do? It was like 22 times 10. So we get like 10 of those, and it's just
Yeah, that part's
two
optional. That's just the way I would split it. But if you
easy.
wanna start with the 22 instead of 13, it's also gonna work. Not the main issue.
Alright, you did it 10 times 22.
Yeah, but if you could also split it as what 20 times 13 plus 2 times 13. Like both splits are going to work out. I just thought this one would be easier, but the other one will also work.
Right. I felt like I was doing it the same as you. I might have been wrong. Okay, so what
You
were you
did it
doing?
more like this, right? The one that's
Uh,
highlighted?
okay. I did it like 20 equals. No, that wasn't my intention. I was trying to do tens and think about it like a 10.
I see you doing
So
13 plus 13, so you had... Oh, did you do, I think you split this one, is that what you did? So you did it like...
okay, this is
You took
like
the 20 and you split it, so did you do this, basically?
uh okay. Uh 20. Okay, this is older stuff. This is what I'm trying to do. Oh wait, this is what I'm
Oh, I was
trying to
talking about what you
do.
did before.
Oh, okay. Then I was confused.
Okay.
Because of that.
Yeah, so the question
Mhm.
was, how do we take this and we split it up into easier multiplications? Because
Okay,
we
so how
split
do
it
we
a
take?
little bit, right? We started with this, which looks hard, and then we split it like this, which looks like easier because now we're doing two easier things. And then how do you split it up into more steps that are even easier?
Okay. I'm gonna try thinking about it like that. Okay, so we have 22 times 13. How do we make this easier? What if we do 20 13s? 20 13s is easier. Okay, what's even easier than that? 10 13s. But then we times it by 2. So we can do like, so yeah, that one is easier. Okay, I'm just gonna leave the 20 13s there. So now what are we doing? We're doing like 2 13s. Wait.
Okay, I'm not sure. Let me show you this. Okay.
Okay.
So we started with this, and then we split it up into the two separate digits. The 13 is a 10 and a 3, right?
The 13 is a 10 and a 3. That is what a 13 is,
So we
yeah.
can split it like this. Now we can take each of these and we can split them more. So the 22, we're going to split it into a 20 and a 2. So we're going to have 10 times 20 plus 10 times 2. That makes sense?
10 times 20. 10 times. Okay, so instead of doing times 22, doing 10 times 20, then 10 times 2. Okay, trying to think about it. That seems like it makes sense, but I'm trying to think about what's happening. 10 twos. Okay, so what is...
So you can think of this as 22 10s added together.
Okay, so... Okay, I'm gonna put this. So, 10 times 22, or 10 times 20 times 2. Wait, okay, so 10 20s. Okay, I'm trying to read your thing, then I want to put it on this thing, so I can look at it and manipulate it. Okay, so what did you do? You have a 15, okay, then you have a 10, 22. And you also have 10, 20. No, sometimes I'm missing things, oops. Okay, plus 3x 2, 2. And this was supposed to be a plus. Okay, so instead of 10 times 22, you can get 10 times 20. Instead of 10, 22, you can get 10, 20, and 10 twos. Okay, so what is this? This is 10, this is 10 22s.
Yeah, but it's easier to say it the other way around for the way we're splitting it. It is 22 10s.
Okay, 22.
That's what I'm splitting it based on. I'm taking there's 22 10s and I'm splitting them into two different groups.
Okay, when I think of it as like 10 22s, I'm still thinking of it as like the 10 primarily or something. Like I want to do something with the 10, not like the 22s.
Yeah, it works either way. Multiplication is symmetric, like it doesn't matter which one's on the left or the right. You can look at it both from both directions. It can be 10 22s or 22 10s. That's the same amount.
I'm always just thinking of it as like being okay, so what is
You
10
could flip it
22s?
around if you
It
wanted
means
to.
you have 22 10 times. Okay, 10 22 means you have 22, but there's 10 of them. And 22 10s mean you have 10s, but there's 22 of them. Okay, so I'm always thinking of it as like there are 10 22s. So you have like a pile of things, and there's 10 of them, and they happen to be 22s. That's how I think about it. Either way, it's
Yep, but it's also a
biased.
pile of 22 tens. Also works.
10 to 10. Okay, and so the 10, there being 10 22s, is the easier way, I think, right?
For what I'm doing right now, there being 22 tens is easier because I'm going to split up the 22.
Oh.
So there's
Okay.
22 tens, but I'm splitting them into two different groups. So that there's one group of 20 tens and one group of 2 tens.
It's going to be one group of 20 tens, one groups of 2 tens. And at the end of the day, when we add those together, it'll become 22 tens again. So, so we have like it's 20. Okay, so
And yeah, Max, I understood what you were saying. That made sense.
Okay, I'm kind of lost. I don't know what we're doing anymore. We're doing something about making things
We're
easier.
simplifying the multiplication. So there's one more step we didn't do yet.
Okay.
So now I'm going to split up the other part. We have 3 22s, or in other words, 22 threes. We can take our 22 threes, and we can change them into 23s plus 2 threes.
Okay.
So does that make sense that that's equal? We're doing the same trick again.
Okay, I think I'm kind of lost in like what the original thing is. So what's the original thing? It's 22 times 3. Then we broke that up to 10 22s. So that kind of just like removes the 3 and like turns that into a 10 basically. Okay, then what did we do here? Okay, what's this doing? This is 10 20s instead of like 22s to make it easier. Okay, right now I think I'm kind of lost. I'm still trying to think about it though. Okay. So if we remove the 2 and the 3, then we could do like 2 times 3 some? Would that work? I don't know. Wait. Okay, so quick question. Would 20 plus 10 oh wait, 20 times 10 plus 2 times 3 be the same as 22 times 13? I'm thinking no.
Alright, let me look at what you were writing. 20 times 10 plus 2 times 3. No. That is less.
Okay.
You didn't get everything. So when I did it, I ended up with this. So we have 20 times 10 here, right?
Okay.
And we
So
have
you
2 times 3 here. I will underline them, right? So these are the two terms that you just mentioned.
Yeah.
But then I also have 2 more terms. I have these other ones as well.
Okay.
So mine adds up to more.
Okay, so let's see what you're doing. Okay, so you have like the 10 times 20, which gets rid of like, okay, 10 times 20, which kind of, what's that doing? It means there are 10 20s. Okay, so we have 10 20s now. Wait, no, this is getting confusing when I say it like that. Okay, 10 20s plus 10 2s. I guess that's to 20.
Okay, well, I have a different way I can show it to you using this grid I brought up. But
Okay.
before that, let me show you the point of this. So the point is now all we're doing is we're multiplying things where there's only one digit that isn't a 0 in every single number, and we're doing addition. So this is easy in some sense because we never have to multiply 2-digit things anymore. It's all, there's one digit times one digit plus some zeros, and that's all we're multiplying every single time. So if you learn your multiplication table, or you can multiply every single digit with every other single digit, then it is now easy to figure out what this comes out to.
Okay, so you can kind of treat it as if it was single digits and then multiply it by tens, I think, is what you were saying.
Yes, all of these multiplications are basically a single digit multiplication plus multiply by 10 some number of times. Just add extra zeros on the end. So they're all really easy if you know your times tables.
So
You
it's
only
like,
have to learn the times tables up to 9 times 9, and then you will be able to do this stuff. Or, I mean, you should learn how tens work, but...
okay, so you can do like 1 times 2, that's 2. Okay,
But you
9
don't have
times
to
a
learn your
base.
times tables up to like 22 in order to do this, because you can split it up so that you only need to deal with things up to 9.
Okay, I don't understand how times tables work. I think that's just like memorizing what like 5 times 9 would be, and like every
Yes,
other
every
in
single
between
combination of
combination.
one digit and one other digit, and what you multiply them with. Oh, the blue pen is this thing called Demo Pro. Max? Yeah, it's this app here, Demo Pro. And it's just using hotkeys, and it's global, and it can write on top of anything. I tried several of these apps, and I thought this one was pretty decent. I did change the hotkeys a little bit. You might want to screenshot my hotkeys. It's just a little annoying because when I'm in terminal and I try to hit Control X, it doesn't work, and I have to quit the app. And I also use these hotkeys in World of Warcraft, so I have to quit for that as well. But other than that, it's nice. Okay, I was looking for times tables. Okay, here's the times tables.
Okay, so you could also like memorize times tables like even above like 10. You could do
Right,
fucking
so you could imagine that this times table keeps going all the way up to 100. And then you'd know how
yeah.
to do 22 times 13 because you're like, oh, I memorized that, it was in the table.
22. Okay, so this times table is like 12 times 12.
Yeah, they do 11s and 12s because, like, a foot has 12 inches, for example.
Huh.
So they're kind of useful numbers, but they're not super important.
So you could also learn like kind of weird times tables. Like if you wanted to, you could learn like the 3 times 100 tables. It's like everything with where like 100, or like everything between 1 to 100 times 3.
You could do that, it wouldn't be that useful, though.
Hmm.
This one is super useful, that's why everyone pays attention to this one. Especially
Ah,
up to 10, but also they throw in the 11 and 12 sometimes.
okay.
The 11s and 12s are not that hard to memorize, especially the 11s. Like, look at this. You see how the digits just repeat, like 44, 55?
Mm. Okay, so 88.
There's a pattern to this column here.
Huh.
You see two of the same number in a row over and over. So 11 times 4 is 44. 11 times 7 is 77.
Ah, yeah.
So that one's super easy to memorize. It doesn't
Hmm.
take much extra work.
So 11 times. Okay, let's do 11 times 4. That's going to be a 44. What if we did an 11 times 26? 26, 26?
No,
10.
11 times things that are more than 9 is harder.
Uh,
Don't worry about it, though. It's just the 11 times 1 through 9 is super easy.
It's still just like adding another 11 though past it. So like,
Yeah, it's not super hard, but it's harder because you have to carry.
okay. Okay, so 12 is the popular because feet.
Yeah, feet and inches is one of the reasons it comes up.
So like if we had a measurement system that like used 13s a bunch, then maybe it would go up to that.
Then people might learn 13s. Yeah, 12 isn't too bad. 11 and 12 because the really important stuff is these 1 through 10. These are what are really important, and then adding 2 more rows isn't a super amount of work. So it's not that big a deal. However, if you tried to make this table a lot bigger, it would be so much work. Like if you had it go all the way up to 20 and 20, the table would be 4 times bigger than if you went up to 10 and 10.
Oh yeah. I don't really know how that works, but I remember it somewhat with like monitor sizes.
Yeah, so if we were going up to 20 and 20, it would look a little bit like this that I'm drawing. So there would be kind of like 4 of the 10 by 10s. Does that make sense? You see
Yeah.
see how I drew them out?
Wait, so is
So
something
like we'd have
exponential?
20 right here. We'd
Is
have
something happening
20
like with
right here.
exponents or something when you do that?
It's just multiplication.
Uh.
We're making both sides bigger. So what happened is we doubled the size, we doubled the width, and we doubled the height.
Mm-hmm.
So the total amount got doubled twice.
Mm-hmm.
When we made the one side go up to 20 instead of 10, now we have twice as many numbers. Then when we do it the other way, we also have twice as many numbers, so it's 2 different doublings, so that's why we got times 4.
Mm-hmm. Okay, so we double twice. That gets us to 4 times. 2 times
Yeah.
2 is the same as... Wait. Timesing something by 2 times is the same as timesing it by 4 1 time.
Yes. Okay, so you see this drawing, I'm going to kill it now, okay?
Okay.
Yeah, so the main thing is people learn their times tables up to 10, maybe 12. And then once you do that, then when you're doing any kind of multiplication with numbers up to 10, or with extra zeros, the zeros don't make it much harder, basically. So if you just have a single digit that's not a zero in each part of the multiplication, and you know your multiplication table, it's easy. So for example, if we had 700 times 90, and you know your multiplication table, it's easy to figure out. So I'll show you how to do that. You can also look up a multiplication table. Anyway, so we have, the numbers are 7 and 9. And you just ignore the zeros. So we find 7 and 9. And here we go, 63. Oh, I didn't mean to delete that. Alright, 7, 9. Alright, there we go. So it is 63. And all we actually have to do, it's a kind of a shortcut, but you just count up the zeros. There's 1, 2, 3 zeros. 1, 2, 3. And we're done. Make sense?
Yeah, so like the way
I
you
just
can do
multiply
it
these
is
two, and then I added all the zeros on the end.
multiply these. That's 7 times 9, you get the 63, and then there's 3 zeros, so you can just add 3 zeros.
Yeah, and then you're done. So
Okay.
all of these things are easy because they're all 1 digit times 1 digit plus add some zeros on the end. So I will go through them quickly. So the first one is 1 times 2 is 2, and then there were 2 zeros. The second one is 1 times 2 again, and 1 0. And then the third one is 3 times 2, that is 6, and then there's 1 0. And then the third one was 3 times 2 is 6, and no extra zeros. So we got that, and then that equals 200 plus these two I'm going to add up to 80. I'm basically going one digit at a time. The first digit is a 2, and then these ones are going to make the next digit be an 8, and then the last digit is a 6. The other ones don't affect the 200, and also the 6 is the only thing that affects the ones digit. It's just that the tens, we have 2 tens and 6 tens, so we got 8 tens.
Okay. I don't know how much I followed along with that. I was trying, but like you're talking and then also highlighting stuff while you're talking, and then the
Yeah.
delay.
Yeah,
It's
it's
bad.
okay. But do you
Okay,
get the
but you
general
said
idea?
I think so. Like with the 20 plus 60. What did you do with that? Alright, I forget what you did with that. You can just like I forget what you did with the 20.
The 200 is 2 hundreds,
Two
like, and then
hundreds. Yeah, there's two
right.
hundreds.
Then the 20 is 2 tens, and the 60 is 6 tens. So these are both tens, so that's why you have to add them together to get 8
So you can
tens.
get 8 tens.
These numbers conveniently, they don't interact very much. Like, I had to add these two together, but I didn't have to do actual addition with the other ones. I just had to put them in the right places.
When you think about it, like 8 tens, like 5 tens, 6 tens, it kind of makes the teen numbers seem a bit weird. Like 18 would make sense for being like 810.
Oh, yeah, 18 is 110 plus 8. Okay. So, yeah, if you can split things up and then use the multiplication table, and then you can figure out large multiplications, like we could do that times that, and it would be a hassle, but we could do it. We could split it all up and eventually figure out what it is.
French names for numbers.
Oh, yeah, different languages have different number systems. Some of them are more annoying than others. I don't know French, but
Yeah, sometimes you can like see Korean numbers and they seem weird because they mix numbers with letters a lot. But it might be similar to just like having, if you have like 1,000, it's just like 1K. That might be similar to what they do with like Korean numbers or something.
okay, now for the 22 times 13, I'm going to show it to you with squares.
22
Okay,
times 13.
each square has 5 in it. They're 5 by 5 squares.
Okay.
So that's 10. That's
Okay,
20,
fine.
and that is 22. So this is 22 long.
Okay, then we could times it
And
by
then that's
5 by
10.
going to
And
4.
this is 1, 2, 3. Um,
Mm,
okay, so this is 13
13.
by 22 rectangle. Make sense so far?
Yeah. That's 13 by 22.
13 by 22 rectangle.
2015. Huh.
Or
So French.
2015 is how you say 95. Yeah, that's inconvenient.
Huh.
Okay, so the first thing, have you seen this kind of thing before? Do you know what this has to do with multiplication?
I think I know what it has to do with multiplication. Like you have 13 grids. Okay, you can. Okay, the 13, it's hovering over 13 grids. So, like, let's just say it was 13 times 1. They'd just be 13 squares and, like, nothing else. But if we move it down 1, then that would double the amount of squares that are captured by it. And if we move it down again, it would triple it, and we could like bring it all the way to 10, and then it would be like 10 times 13 squares. And then you could also do it with like all the way to 22, and then you get 22 times 13 squares. Yeah,
Yep.
I also remember thinking about it once, and I figured out you could do it diagonally to figure out the size of like a grid selection, whatever.
That is
Like,
more complicated. Anyway,
yeah.
okay, so how many total squares are in this rectangle?
How many total? There would be 13 by 22 squares. So, I don't know if I'm supposed to be figuring out the answer right now.
Well, we already multiplied 22 by 30.
Oh, okay, so 286.
Yeah, okay. So, first thing you should notice about this is you can turn it sideways. I wonder if there's a command for that.
Oh shit, so right now it's like 13 by 22. We could flip it around, and then it's 22 by 13. Yeah, that makes sense.
Rotate left. That didn't rotate all the way. Really.
Is there a shortcut?
Probably. There. Anyway, I did it. Okay, now how many squares are there?
Okay, I'm gonna imagine the 22 is on top, so it would be 22 times 13 squares.
Yes, so it's the same number of squares when we turn it sideways.
I remember doing things with like kind of sticks of numbers. It was like one stick had 10 numbers in it, and it was like 10 long. And you could imagine it if it's just like an upright, then it's like 1 times 10. But if you put it on its side, wait, how do you do it? Okay, there's one
Then it's
thing
10 times 1.
of
Or 1
10
times 10, yeah.
squares. Yeah.
You can put it sideways and it's the same amount.
Yeah, blocks are nice for thinking about math, I think.
Okay, so you can see it as 22 13s or 13 22s. So 22 13s, we have 22 of the rows, because each row is 13 and there are 22 of them. However, I'll wait for delay. You see what I was drawing? Make sense?
Yeah.
Okay, we can also see it as 13 22s, which are currently the columns. Every column has 22 squares in it. And then there are 13 columns.
There's 22 squares in it. Yeah. Each column is of 22. And then there's 13 columns.
Yep, so does that make sense?
Yeah.
Okay, and then when we're splitting it up to make the math easy, I will show you how that works in the grid.
So you can like
we're going to go here because this is 20. We're going to go here because this is 10. So now I have the 10 by 20 part. 10 by 20. And then we're going to divide it into these other little parts. And what are these? We have a 10 by 2 by 10 part. Then over here, this is 20 by 3. And then down here, we have 3 by 2. Does that make sense?
Okay. 320, then 10. Wait, what's the 10 part?
This?
Yes.
This 10 is the length of the side right next to it. From here to... Let me get a different color. The 10 is that length. I just didn't want to write it inside. And then the 2 is this, the height. This is 2 by 10 is the number of squares right here.
That's a 2 on the left.
Yeah, that's a 2.
Yeah. It's hard to see.
Yeah, it's not the best handwriting. This one is a 3 over here. 3, 2.
If I was more used to handwriting, I might have been able to read it, but I'm very bad at handwriting. It's something I think I want to get better at. Not much, but just like enough to read and write.
Yeah, I learned handwriting in school long ago, and I am mediocre at it and do not plan to get better.
Okay,
It's
I
it's
think,
harder with a mouse. I could do it better with like a pencil.
yeah. Okay, I'm going to do something. What is that something? BAFK to eat food. Yes.
Oh, how long?
I think like 10 or 5 minutes, about that amount of time.
Do you want to finish looking at this first?
Okay.
Did you see how I split it up? Did that make sense?
Mm. Yeah, so like what are we doing? We're doing 10 times. Okay, so basically, original thing we're trying to figure out is 22 times 13. So we can make it easier by just like removing the 2, removing the 3, and then it's just like 10 times 20. Okay, then like what is everything we're missing? We're like missing 20, 3 by 20, we're missing 10 by 3, and we're missing a 2 by 3. So we need to like do those individually, and then we can figure out the results for all of those. So we can do like 10 times 20 equals 200, like 20 times 3 equals 60, 2 times 3 equals 6, and then like 2 times 10 equals 20. And then you can add all those together, and you can get the answer for 22 times 13.
Yep, and do you see how this is the same method that I was doing with numbers before?
Okay, it's like 10 times 20, yeah,
I'm
and then
drawing the
10
connecting
times
lines to
2.
each of the
So,
things I was splitting it up into turns out to be one of the boxes.
oh yeah, that makes sense. I see the connection lines and the 3 times 2. Huh. Yeah, thinking of things physically as boxes seems good. Okay, I'm gonna go AFK to.
Okay, yeah, I'm gonna end stream now. Okay?
Okay. Okay.
Bye.